Hello connections. I'm back with the new and another exciting video. In this video is basically on the stock market prediction, price prediction, and this is very exciting video. I hope you will enjoy. But I will make sure that please do not make any decision from this particular video in your real stock price. It's old data, so that's why I have told you. So quickly, I'm going to start. I'm sharing my screen. This is the raw data of which I have taken from the Kaggle and my drive. Let me show you the data. This one is the data. There are 1, 2, 5, 9 rows and 14 columns, which is 14 column. A is just a serial number, date, close, high, low, open, volume. This is the only relevant for me. The remaining one is not relevant for me. So whatever I have predicted in my data, in my project, is basically on from this date, close, high, low, open, and volume. This one is for relevant for me. So quickly, I'm back with the CSV file. This is my CSV file, and let's start. This is the task 2 of my internship, and the stock price prediction is the topic. And this is this photo I have taken from the Google to show you this to show you the how the stock price looks. So here I have imported the important libraries, and then after I have imported my file CSV file from my Google Drive to this notebook. Then what I have done is I have just see the whatever inside my data I have to see. For that I have written df, so it shows my whole data. There are 1, 2, 5, 8 rows and 14 columns. Then after head and this tail, for tail this one is, and the unnamed 0 is irrelevant for me, because already there is the written 0, 1, 2, 3, 4. So unnamed 0 is irrelevant. So what I have done is, in the next, I have just dropped the unnamed 0. In place is equal to 2. It will give the permanent decision. So then after df is equal to this, it means I have successfully removed the unnamed 0. Then I have changed the format of the date. Here it looks like something very difficult to read for everyone. So what I have done is I have just changed the format of the date, so it looks quite much better than the previous one. So then after I have taken the information of the data set, here are all are not non-null value. Date is objective, close is float, integer is integer 64 is volume, and this one is volume, and this one is integer 64, and this also one the integer 64, which is irrelevant for me, but what should I do? It's a data. So and then after I have checked is there any null value in my data set, and if it yes, then it will give me the sum of how many null values inside my data set. So it shows 0, 0, 0 everywhere. It means there is no null value inside my data set. So what I have done in the next part is I have just taken the description of my data set, how many counts, what it will be the mean of every column's standard deviation value, and the minimum value, maximum value, and 75%, 25%, and the 50 percentile of my data set, the number, actual number. So that will gives my that will give the result that will very helpful for my taking my decision for the next line. So what I have done is the next line is I have checked the how much length of the my data set. So for this, I have just written the code print the length of the data set is length LENTF. It will give the premium quality of your data set, just like this one. Apart from this, I can just put print length df. It will also gives you the data, but this will show the actual premium quality. So that's why I have written. Then after I have checked the shape. Then for the open, this this data open column, I have plotted into the graph how it's look. So this for making this graph, I have just mentioned the df open column plot graph fig size is equal to 10 into 4, and it means 10 from here to here 10 and here to here 4 and this was just x coordinate and y coordinate same as, and plt dot show. Then it will show this graph. Then after I have just splitted my whole data into two parts. How much what the data I have relevant, I have just split into two parts, x and y column. So in the X part, I have taken the open, high, low, and volume, and the close in the close Y section, I have taken just close. Here you can print this X, then you will get the open, high, low, volume, and there are 1,258 rows and 4 columns, as you can see here. 4 columns is open, high, low, and the volume. All are 4. So that's why. Then after what I have done is I have also printed the y, what my y says. Y is just a closing value 132, 131, 130, 130, 129, and so on. The column name is close, the length is 1258, and data type is float. Then after I have just making the machine. So that's why for making this, I have just written a code from sklearn.model selection import train and test split xtrain y test xtrain x test y train y test and text train test split xy random state is equal to 0. So in this from this line, I have just taken the whole my data, which I have taken xy as xy. I have taken all the data to train and test split. I haven't split any my data into 80, 20, 50, 50, 70, 30. No, I have taken all the data. So it will give the better result, or maybe the zero result, or it will fails, not perform very well. So that I will say in the last part. So from this, I have just imported this, and then I have checked this xtrain shape is 943 into 4, and the y test is 315. If you add this one and this one, it will gives you the 1257, the actual data. So I haven't split it into its 18 to 20 part. So in the next line, what I have done is from sklearn the linear model, I have made the linear regression model. So it will give the accuracy level very high in my prediction data. So that's why I have taken the linear regression. Every model is good, but in this for this particular project, I have taken the linear regression. So in the next line from sklearn dot matrix, imported the confusion matrix, accuracy scores, and regression is equal to linear regression. That will show the linear regression is very much successful train format X train and Y train. So in the next line, what I have done is I have printed the regression dot coefficient. It will give the minus 5.7, 6.8 is into 10, 8.8 and minus 1.0. And then after I have taken the print of a regression intercepts, it will give 0.11. Then predicted. The most important thing is the predicted. The regression is not predicted is equal to x test. For the x test, I have taken the regression and named the predicted. Then x test, I have just x test. I have just taken the one open close. That's a random data, and this open high low and the volume, it will gives the 1 minute. Okay, okay, this is the actual data x test. Open, let me show you the open part. Open 5. Open 4. Here I can show you df dot head 5. Here you can see that the open 130 high is 132, but my predicted is 130, and the low is 130, but my predicted is 129, and the volume is 458 something. But my predicted is 309.8 something. Okay, that's my predicted one. And then after what I have predicted dot shape, the shape of this predicted point is 315. And then after I have split my actual data into predict and the predicted data, so that I can just okay, my mistake. I have done the mistake. I have to write here 6. Okay, I have to see this one. Okay, because this one is 5th number. Open is 130.66. Okay, high is 130.94, and the low is 129. Okay, and the volume is this one. Here you can see. So the it's my test data, and after that I have done is I have made a data frame, new data called data frame, short form DFR. And what I have done is the actual data, I have stored the actual data and the predicted data. What the actual data I have and what the predicted data, what my machine has guessed or my machine has predicted, I have stored in DFR. So here you can see DFR. This is my actual data and this is my predicted data. Here you can see the closing price. This is for the closing price. So here you can see the close, for the 5th column. Fifth column is 130, 130.120. Here is the actual data 130.1012, and my machine has predicted 130.4, which is quite negotiable, but not accurate. But I think it will gives the 99.999% accurate. Somehow my data not work, my machine has not worked well, so that's why it will give some error. So here you can see the 153.95 and 0.73. So some slightly difference from the actual data to my predicted data, but all are same. Here you can see this one is one difference. Difference is one, approximately one is difference. Okay. So in the next line, I have seen the accuracy scores in the percent form. So here you can I can see my test and X test and Y test in the percent form is 99.9%. It means my machine is working very well, and it gives 99.99%, sorry, 99.93% correct. So it predicts the same as the actual data, but 99 with the percentage of accuracy level 99.9. Okay. Then after I have made a graph data frame data, and here what I have done is I have stored the data frames here in 50 data, so that I can make a graph on this. So in the next line, I have plotted a graph that my actual data and my predicted data, how it's looked in the bar format. So here you can see that the almost same, both are almost same. The actual data and the predicted data is same, but the slight difference. Here is the difference. Here is the difference, and this one is the difference. Actual data is very high, but my predicted point is quite low. Here you can also see the difference. Here you can see the difference. So almost same, but some with the accuracy level 99.9%, my predicted point is working. So, and the from above the graph, it is clear that my actual and the predicted point is almost same, and the accuracy level is 99%. Okay, here I can make a change 0.9%. So from this, I am winding off this project. This is my whole data, and this is my whole project on stock market price prediction. So from this, I'm quickly signing off from my side, and I will upload my next project soon. I hope you will also like this session, and you will like this that one also. And if you want to give me some suggestion that you have to do this, and you have to make us some changes, like then you can also comment in the description box. It will open for all. So bye from my side. Thank you.